The REAR protocol has been designed and implemented for advertising and negotiating cloud resources involving two key entities, the consumer, on the upper left side, and the provider, on the upper right side. Those entities are typically Kubernetes clusters that are independent with one another. In our case, those clusters already know each other, but they do not know which resources are available on the other cluster. This is when the protocol comes into play. The REAR protocol supports the negotiation of computational resources like virtual machines or Kubernetes clusters, but also for software services such as a database instance or message queues. We will refer to any kind of resources as flavor. The consumer initializes the protocol entering the retrieve flavor phase. It initially sends a list flavor message, where it can specify some filters, for example, a VM with at least 8 GB of RAM. If the provider has anything to share, it will send back a list of flavors to the consumer. Then, after selecting a flavor, the consumer starts the negotiation entering the reservation phase. It sends the reserve flavor message specifying the flavor it wants to negotiate. If the flavor is still available, the provider creates a transaction object which maps the flavor with the entity involved, the consumer and the provider. It also sends back a timer, TTP, which stands for time to purchase, within which the consumer needs to confirm and finalize the payment. This is when the consumer enters the final purchase flavor phase, where the consumer can confirm the payment by sending the purchase flavor message. If the provider successfully receives this message, it will draft a contract which will contain all the claims of the negotiation. The REAR protocol terminates once the consumer receives this contract object created by the provider. This is the dashboard of our consumer cluster. As we can see, in this overview section we already have info about the remote provider clusters, named remote FLUIDOS nodes here, by their IP addresses and ports used for the REAR protocol. We can also see metrics about the local resources, that are mainly Kubernetes nodes this case, so we see CPU and memory usage and availability. If we go to the flavors section, we roughly have the same info into the local tab. However, we have nothing to show when looking into the available section as we did not trigger any request yet. This section shows what are the resources available into remote clusters. Also, the acquired section is still empty as we did not reserve and purchase any flavors yet. We can also add flavors manually, but this is going to be skipped for the sake of time. In our current implementation, the REAR protocol messages and objects have been implemented through Kubernetes CRDs, custom resource definitions. In order to kick off the protocol, we need to create a list flavor message which will be sent to the list of available providers. This message is mapped to a CRD named solver, so we can create such a request by creating a solver object. We name it solver1. We can also select a specific type of flavor. If we do not specify any type, we can retrieve back all the flavors available on the provider clusters, regardless of their type. For the sake of simplicity, we're going to select Kubernetes Slice, which is a Kubernetes node. We have some specific fields for the type. We can leave those flags enabled so we can automate all the steps of the REAR protocol. We can specify some optional fields, in terms of CPU, memory, number of pods, which are relevant information for Kubernetes node resources. We can then send this request. If every steps have been correctly executed, they will be marked as solved. This is when the solver object ends to be successfully fulfilled. Now, the remote objects given by the initial retrieve flavors message can be seen under the Available tab into the flavor section. Since all the steps have been automated, we also created a reservation object mapping both reserve and purchase message, but also a transaction object, and a contract which ensures us the protocol terminated successfully. We also have another object named allocation. It goes beyond REAR protocol and the scope of this demo, but this is used by the consumer to offload tasks onto the remote provider clusters, and it ensures that the consumer uses the right amount of resources. If we now go into the flavor section once again, we also see all the information about the flavor negotiated through the REAR protocol under the Acquired tab. This concludes our demo.